Hello students of class 8. This is your chapter 4, cubes and cube roots. So the cube of a number is that number raised to the power 3. Thus if x is a number, then the cube of x is x cube. That is, x cube is equal to x into x into x. The cubes of numbers 1 to 20 are given below. These are the numbers given below. So from this, it is observed that the cubes of even numbers are even and the cubes of odd numbers are odd. You see, the cubes of even number, 2 cube is 8, okay, 8 is an even number, and 3 cube is 27, 27 is an odd number. 4 is even, so 4 cube gives me an even number. 5 is odd, so 5 cube gives me an odd number. Similarly, 6 cube, 6 is even, so 6 cube gives me an even number. 7 is odd, so 7 cubes gives me an odd number. So therefore the cubes of even numbers are even and the cubes of odd numbers are odd. Next, the cubes of a number ending in 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 ends in 0, 1, 8, 7, 4, 5, 6, 3, 2 and 9 respectively. So therefore, if the last digit of a number is 0, if the last digit of a number is 0, okay, let's say this is, let's say the number is x and the last digit of x is 0, then x cube, the last digit of x cube, it will be also 0. If the last digit is 1, then the cube, if the last digit of the number is 1 and cube of that number, in that last digit, okay, the last digit of the cube of that number, it will also be 1. If the last digit of the number is 2, then the last digit of its cube, it will be 8. Similarly, if 3, then it is 7, 4, then it is 4, then again 5, then it is 5, 6, then it is 6, 7, then it is 7, then it is 3, 8, then it is 2 and 9, then it is 9. Okay, so therefore our example 1 here, example 1, find the unit digit of the cube of each of the following numbers. Find the unit digit of the cube of each of the following numbers. Okay, example 1. Find the unit digit of the cube of each of the following numbers. So first it is our 2331. Okay, 2331. So the last digit of this number, it is 1. So therefore cube of this number 2331, the last, or you can say the unit digit of the cube of 2331 is 1. Next it is, you see, the number is 8888. The last digit of this number is 8. So therefore the unit digit of cube of 8888. So if the last digit is 8, then the unit digit of its cube, it will end with 2. Understand? So the unit digit of cube of this is 2. Next, similarly, number 3, it is 249 given. Okay, 249 given. So 249 cube if you do, okay, 249 cube if you do, then what will be the last digit of that cube? What will be the last digit of that cube? This number ends with 9, so therefore its cube will also end with 9 only. Understand? So you can write the unit digit of cube, the unit digit of cube of 249 is 9. Understand? The unit digit of cube of 249 is 9. So similarly, rest we can find this number. You see it ends with 5. Okay, this number it ends with 5. So this number you see it ends with 5. So the unit digit of cube of this number it will be 5. And then this number you see it ends with 4. So therefore the cube of 3024, okay, unit digit of the cube of 3024, it will be also 4. Okay. Next, perfect cube. A natural number is said to be a perfect cube if it is the cube of some natural number. Okay, a natural number is said to be a perfect cube if it is the cube of some natural number. In order to check if a given natural number is a perfect cube or not, we follow the following procedure. So first you see example 2. Okay, we will do from example 2, asking that is 648 a perfect cube. Okay. As while doing our previous chapter, squares and square root, you can see in order to check whether a given number is a perfect square or not, what we used to do, we used to take out its prime factorization. And then its factors, I make it into a group of 2 factors. Yes, I make it into a group, and in each group there are 2 factors. Yes. Now in cubes, when I will make those groups, in one group there will be 3 factors. Okay, in one group there will be 3 factors. Okay, so if after doing the prime factorization, if all of the factors are grouped, okay, if all of the factors are grouped and no factor is left behind or left over, then I can say that 648 is a perfect cube. Okay, and if some factor is left over, it does not forms a group, then we can say that 648 is not a perfect cube. So now you see example 2. Example 2 asking that is 648 a perfect cube? Is 648 a perfect cube? Is 648 a perfect cube? So I can write like that, that resolving 648 into prime factors, resolving 648 into prime factors, we get, resolving 648 into prime factors, we get, okay, 648, if I take out the prime factor of 648, you see 2, 2 3s are 6, 2 2s are 4, 2 4s are 8, 2, 2 1s are 2, 2 6s are 12, 2 2s are 4, 2, 2 8s are 16, 3, 27, 3, 9, 3, 3, 3, 1. Okay, so therefore 648 I can write it as 2 into 2 into 2. Okay, you make a group in which there will be 3 factors. You see 2 into 2 into 2, one group, again 3 into 3 into 3, 3 into 3 into 3, another group, and last 3. So you see these 3 factors, it is left over. These 3 factors does not make a group, it is left over. Understand? So therefore, clearly in grouping the factors in triplets of equal factors, we are left with 3. So therefore, 648 is not a perfect cube. Okay, as it is given in your book, you see first of all, they have taken out the prime factorization of 648, and grouping the factors in triplet of equal factors, we get this. Clearly in grouping the factors in triplets, of equal factors, we are left with 3. So therefore 648 is not a perfect cube. So instead of writing all of this, you can write we observe that factor 3 is left, factor 3 is left over. Factor 3 is left over we observe that factor 3 is left over in grouping. We observe that factor 3 is left over after grouping um, we observe that factor 3 is left over after grouping. So therefore 648 is not a perfect 648 is not a perfect cube. Okay, therefore 648 is not a perfect cube. So first of all, is this a perfect cube? Resolving this into prime factors, we get prime factorization I have to do. So 648 is equals to this one I will get. Okay, in here in one group we will put 3 equal factors. Okay, and in one group we will put 3 equal factors. Understand? So in here you see after grouping it is observed that factor 3 is left over after grouping. Okay, so therefore 648 is not a perfect cube. Okay, next again example 3. Now is 27000 a perfect cube? Find the number whose cube is 27000. So solution here you see is 27000 a perfect cube. So first of all I will take out the prime factorization 27000. So 3 9000 3 3000 3 1000 5 200 5 40 5 8 2 4 2 2 2 1. Okay, this is the prime factorization of 27000. So now therefore I can write 27000 it is equals to 333 3 into 3 into 3, this is one group, into 5 into 5 into 5, this is one group, and into let me write it. Therefore 27000 this is equals to 3 into 3 into 3 into 5 into 5 into 5 into 2 into 2 into 2. Okay, so therefore you see each of these factors 3 5 and 2 they are forming the group perfectly. Yes, they are forming the group perfectly. There is no factor is left over. So therefore uh, I can write we observe that no factor is left over. We observe that no factor is left over after grouping. No factor is left over after grouping. Therefore 27000 is a perfect cube. Okay, is a perfect cube. Next it is asking find the number whose cube is 27000. Okay, so find the number whose cube is 27000. That means now I will have to find which number cube it is equals to 27000. Okay, so you see, when we did the prime factorization, I rubbed it. When we did the prime factorization, we got 3 into 3 into 3 into 5 into 5 into 5 into 2 into 2 into 2. This one I got. Yes. Now, um, now find the number whose cube is 27000. The required number whose cube is 27000 is, which number cube is 27000? So if from here you see, from each group one factor I will take. 3 into 5 into 2, this is equals to 30. So therefore 27000 is the cube. 27000 is the cube of 30. Okay, 30 cube if I do, 30 cube 30 cube if I do, I will get 27000. Understand? So this is the answer here. So first of all, in the question it is asking that is this number a perfect cube? You take out the prime factorization, and in prime factorization the factors I will group it. Okay, the factors I will group in triplets of equal factors. Like that, these factors I will group it, and after grouping I have found that no factor is left over. Yes, no factor is left over. So therefore the required number whose cube is 27000, from here I got that no factor is left over, so therefore I can say that 27000 is a perfect cube. And the required number whose cube is 27000 is, from each group you take one factor. This is 3, this is 5, this is 2. So 3 into 5 into 2 I will get 30. So therefore 27000 is the cube of 30. Next again, example 4. What is the smallest number? Example 4 in here. What is the smallest number by which 392 must be multiplied so that the product is a perfect cube. Okay, so in here again I will take out the prime factorization. Of 392. So prime factorization of 392, 2 ones are 2, 2 nines are 18, 2 6 are 12, 2 nines are 18, 2 8 are 16, 2 4s are 8, 2 nines are 18, 7 sevens are 7, 1s are. Understand? So therefore 392 is equals to 2 into 2 into 2 into 7 into 7. Okay, 2 into 2 into 2 into 7 into 7. Now you see, this 392, it is not a perfect cube. Yes, this 392, it is not a perfect cube. To make 392 a perfect cube, I will have to multiply 7. With 392. So therefore, what must be multiplied so that the product is a perfect square? Yes, what is the smallest number by which this should be multiplied so that the product is a perfect cube? Now, after prime factorization, we have seen that again one factor 7 is required. Understand? Again one factor 7 is required, because in here I am not able to make the group of 7. Yes, 7 only 2 there. I need 3. I need 3 7 to make one group. So therefore, you can write, it is observed that um, the smallest number by which 392 must be multiplied must be multiplied so that the product is a perfect cube, it is equals to, so that the product is a perfect cube is 7. Okay, it is observed that the smallest number by which 392 must be multiplied so that the product is a perfect cube is 7. If I multiply 392 with 7, then then the product will be a perfect cube. Okay. Next again, example 5. What is the smallest number by which 3087 must be divided so that the quotient is a perfect cube? 3087. Okay, question asking here. Example 8. Question asking here. What is the smallest number by which 3087 must be divided? Okay, in here divided, must be divided. So again, solution, what I will do, I will take out the prime factorization of 3087. So prime factorization of 3087. So this one, if I take out the prime factorization 3087, this one I think will go with 3 ones are 3, 3 zeros are 0, 3 twos are 6. Let me divide it in here. 3087 by 3. 3 ones are 3, 3 zeros are 0, 8, 3 twos are 6, 2 7, 3 nines are 9. Again, this one will it go by 3. 3 threes are 9, 1 2, 3 fours are 12, 9, 3 threes are yes, 3 4 3. This it will go by 7. 7 3 4 3, 7 fours are 7 fives are 7 fours are 28. 14 minus 8, 1 2 3 4 5 6 3, 49 I will get 7 7 7 1. So therefore 3087, this will be is equals to 3 into 3 into 7 into 7 into 7. Okay, now what is the smallest number that 3087 must be divided? What is the smallest number 3087 must be divided so that the quotient becomes a perfect cube? Okay, so that the quotient becomes a perfect cube. So in here you see, from this prime factorization, I was able to make the group of factor 7, but factor 3 group I was not able to make because one factor 3 is missing here. Understand? So therefore this 3 into 3 I will have to remove. Understand? If 3 into 3 if I remove, then I will get 7 cube. Yes, then I will get 7 cube, which will become a perfect cube. Understand? So from this, what is the smallest number that I will have to divide 3087? The smallest number will be 3 into 3, that is 9. Understand? So therefore we can write it is observed that the smallest number, therefore it is observed that the smallest number by which 3087 must be divided so that the quotient QUOTINT, so that the quotient becomes a perfect cube, it is equals to 3 into 3, that is equals to 9. This is our answer. So if I divide 3087 by 9, then our quotient, it will become a perfect cube. Understand? Next again, properties of cubes of numbers. Okay, properties of cubes of numbers. So first property, it is cubes of all odd numbers, cubes of all odd natural numbers are odd, cubes of all even natural numbers are even, cubes of digits 1, 4, 5, 6 and 9 are numbers ending in the same digit respectively. Cubes of 2 ends in 8 and cube of 8 ends in 2. Cube of 3 ends in 7 and cube of 7 ends in 3. Okay. Cubes of negative numbers are negative. Okay. Cubes of negative numbers are negative. Negative 1 the whole cube, it is equals to negative 1. Negative 2 the whole cube, it is equals to negative 8. Negative 3 the whole cube, it is equals to negative 27, and so on. Okay. If a number ends in a 0, its cube will end in 3 zeros. Understand? If a number ends in a 0, for example like 10, it ends 10, it has 1 0 at its end. Yes, it has means the unit digit of 10 is 0. Yes, it has got only 1 0. So 10 cube, okay, cube of 10, the answer, it ends in 3 zeros at its end. Okay, 20 cube, it becomes 8000, it ends with 3 zeros. So therefore if a number ends in a 0, its cube will end in 3 zeros. For any rational number a by b, we have a by b the whole cube, it becomes a cube by b cube. Understand, these things we have already learned. Next it is example 6. You see, so that minus 1728 is a perfect cube, find the number whose cube is minus 1728. Okay, in here saying that, so that, this is example 6. Example 6, so that minus 1728 is a perfect cube. Find the number whose cube is minus 1728. Now in here you see this number, it is negative there. This number, it is minus 1728. It is not a positive number, it is a negative number. So I have to see whether this number is a perfect cube or not. So you no need to look at the negative sign. Okay, no need to look at the negative sign, because the cube of a negative number, it is whatever the answer you will get, it will be a negative number only. Understand? So therefore in here I have to show that minus 1728, it is a perfect cube. So again I will, in here I will take prime factorization of 1728. I will take out the prime factorization of 1728. So prime factorization of 1728, in here I got, you see, 2 2 8 is 16, 2 6 is 12, 2 4 is 8, 2 2 4 is 8, 2 3 is 6, 2 2 is 4, 2 2 2 is 4, 2 1 is 2, 2 6 is 12, 2 2 1 is 2, 2 0 is 0, 2 8 is 16, 2 54, 2 2 2 is 4, 2 7 is 14, 3 9 is 3, 3 is 3, 1 is finished. This is you see, this is 3 2 is 6, and then 6 2 is 12, and then again 3 2 is 6, 6 2 is 12, and then 3 2 is 6, 6 2 is 12. So this one I can write as 12 into 12 into 12. So minus 1728, I can write it as minus 12 into minus 12 into minus 12. So therefore minus 1728, this is equals to minus 12 the whole cube. Okay, so therefore I can say minus 1728 is a perfect cube, and minus minus 1728 is the cube of minus 12. Okay, so this one in here, first of all, so that minus 1728 is a perfect cube. So first of all, I will take out the prime factorization of 1728. Okay, I will take out the prime factorization of 1728. This one I will get 2 8 is 16, 2 6 is 12, 2 4 is 8, 2 4 is 8, 2 3 is 6, 2 2 is 4, 2 2 is 4, 2 1 is 2, 2 6 is 12. This one again 3, 3 7 is 21, 3 2 is 6, 3, 3 2 is 6, 3 4 is 12, 3 8, 2 4, 2 2 2 1. Okay, so therefore in here these factors I can multiply it in this way. You see 2 3s are 6, 6 2s are 12, again 2 3s are 2 3s are 6, 6 2s are 12, again 2 3s are 6, 6 2s are 12. I can multiply in this way, so I will get 1728. It is equals to 12 into 12 into 12. So therefore minus 1728 I can write it as minus 12 into minus 12 into minus 12. So therefore minus 1728, it becomes minus 12 the whole cube. So therefore minus 1728 is a perfect cube. I can say that minus 1728 is a perfect cube, and minus 1728 is the cube of minus 12. Next you see example 7. Consider the following pattern. Okay, example 7, it is saying consider the following pattern. 2 cube minus 1 cube, this is equals to 1 plus 2 into 1 into 3. 3 cube minus 2 cube, it is equals to 1 plus 3 into 2 into 3. 4 cube minus 3 cube, this is equals to 1 plus 4 into 3 into 3. So using the above pattern, find the value of number 9, 9 cube minus 8 cube. Using the above pattern, find the value of. So this is, you see the pattern, 1 plus 2 into 1 into 3. Okay, 1 plus 3 into 2 into 3. Next again 1 plus 4 into 3 into 3. Okay, 1 plus 2, you see 1 plus 2 into 1 into 3. 1 plus 3 into 2 into 3. 1 plus 4 into 3 into 3. So this it will become 1 plus 9 into 8 into 3. Okay, 1 plus 9 into 8 into 3. This will become 1 plus 216, which is equals to 217. Next again 12 cube minus 11 cube. This will become 1 plus 12 into 11 into 3. This will become 1 plus 396 is equals to 397. Next it is given 20 cube minus 19 cube. This is 1 plus 20 into 19 into 3. This becomes 1 plus 1140 is equals to 1141. Next it is your 51 cube minus 50 cube. This is equals to 1 plus 51 into 50 into 3. This becomes 1 plus 7650, which is 7651. Okay, so now we will go to our next topic, that is cube root. I will go to our next topic, that is cube root. So a natural number m is the cube root of a natural number n if n is equals to m cube. then we write cube root of n equals to m. Thus cube root of n equals to m. This is, I can write it as n is equals to m cube. Same means this arrow it is given, both side arrow given. Understand? That means if this is given, I can write this one as like that, or I can write this one as in this way. Okay. So now you see, next cube root of a perfect cube by factors. Okay, if I want to find the cube root of a number, okay, cube root of a perfect cube. This is our example 8. In here we are finding cube root. In here we are finding, you see, cube root of a perfect cube. Cube root of a perfect cube. So example 8, in here first find the cube root. Find the cube root of the following. Find the cube root of the following. First it is 216. So in here what I will do, I will take out the prime factorization of 216. Okay, prime factorization of 216. So 3 7 ja 3 2 ja 3 3 2 ja 6, 3 4 ja 12, 3 8 ja 2 4 ja 2 2 ja 2 1 ja. So therefore 216 is equals to, I can write it as you see 3 cube into 2 cube. Yes, 216 I can write it as 3 cube into 2 cube. You understand? So therefore I will take cube root both side. Cube root of 216, it will be cube root of 3 cube into 2 cube. Understand? So therefore cube root of 216, it will be is equals to, in here again you see cube and cube root, it will cancel out. Okay, cube and cube root, it will cancel out. Understand? Similarly, such as in square root we have learned that square and square root it cancels out, like that cube and cube root it will cancel out. So ultimately I will get 3 into 2, which is equals to 6. So cube root of 216, it is equals to how much? It is equals to 6. Okay. So similarly you see next one it is given 91125. Okay, so again we will find out the prime factorization of 91125. So prime factorization of 91125, 5 I will get 18225, again 5 I will get 3645, again 5 I will get 729, 3 I will get 243, 3 I will get 81, 3 I will get 27, 3 I will get 9, 3 I will get 3, 3 I will get 1. So therefore 91125 I can write it as cube cubic, 5 cube. You see this is 5 cube into 3 cube, 3 cube into 3 cube, 3 cube. Okay. So therefore cube root of 91125, this is equals to cube root of 5 cube into 3 cube into 3 cube. So again cube and cube root it will cancel. So I will get 5 into 3 into 3. So this is 3 3 is a 9, 9 5 is a 45. So cube root of 91125, it is equals to how much? It is equals to 45. Understand? So now next example number 9, you see example number 9 it is given. Find the smallest number which when multiplied with 3600 will make the product a perfect cube. Further find the cube root of the product. Okay, so in here asking that with 3600, with what is the smallest number that I will multiply with 3600 such that the product it will become a perfect cube, such that the product will become a perfect cube. Understand? So in here first of all I will take the prime factorization. Okay, I will take out the prime factorization of 3600. I will take out the prime factorization of 3600. So this is 3 1 3, 3200, 3 400, 2 200, 200, 2 50, 5 10, 5 2 2 1. Okay, prime factorization. So therefore 3600, I can write it as, you see, this is 2 into 2 into 2, 1 2 cube I got here, 2 cube into this one, you see, 3 into 3, this is 3 into 3 there, and this is into 5 there, and this is into 2 there. Understand? So therefore we observe that um, uh, we observe that the smallest number, that must be the smallest number that must be multiplied, with 3600 to make it a perfect cube. It is equals to, you see, this 3, there are 2 3, I need one again, 1 3 I need, so that I can make the group of 3. Again there is 2 5, again 1 5 I need to make the group of 5. And okay, and last, you see, with this 2, to make it a group, again I have to multiply it with 2 2's I will have to multiply. Yes, again 2 into 2. So therefore we observe that the smallest number that must be multiplied with 3600 to make it a perfect cube, it is 3 into 5 into 2 into 2. Understand? This is equals to, I will get 5 3 is 15, 15 2 is 30, 30 2 is 60. So 60 is the smallest number that that must be multiplied with 3600, so that their product becomes a perfect cube. Understand? And then the question it is asking that further find the cube root of the product. Okay, further find the cube root of the product. So therefore product of, I will write product of 3600 and product of 3600 and 60, this is equals to 3600 into 60. So this is, I will get 36 into 6, 6 6 are 36, 3 6 are 18, 19 20 21, 216000. This will be the product of, and then I will find the cube root of 216000. This will be is equals to okay, so first of all I will write the, you see, 216000, it's a prime factorization. You see, already we have got 2 cube, then we will get 5 cube, then we will get 5 cube, then we will get again 3 cube, then we will get again 2 cube I will get. Yes, again 2 cube we will get. So therefore the cube root of 216000, this will be cube root of 2 cube into 5 cube into 3 cube into 2 cube. So therefore you see, cube and cube root, it will cancel out. Cube and cube root will cancel out. So it will give me 2 into 5 into 3 into 2, which ultimately gives me 5 to the 10, 30, 30 into 2, 60. So therefore cube root of 216000, this is equals to how much? This is equals to 60. This is our answer. Okay. Next, again our example example 10. Example 10. What is the smallest number by which 3087 must be divided so that the quotient is a perfect cube? Also find the cube root of the quotient so obtained. Okay, what is the smallest number by which must be divided? Okay, what is the smallest number by which 3087 must be divided so that their quotient becomes a perfect cube? Okay, so this one, as we have done in square root, same thing. Again we will take out the prime factorization. Okay, again we will take out the prime factorization of 3087. Okay, you write it, the prime factorization of 3087. So prime factorization of 3087 I will get here. This is 7 147 721 7331. So therefore I can write as 3087, this is equals to 7 cube into 3 into 3. Okay, 7 cube into 3 into 3. Now you see 7 cube I got, but 3 cube I am not able to get, because in here one 3 factor was required, another one into 3 it was required, then only I can make it into 3 cube. But in here it is only 3 square, there another one factor it is required. So therefore, what is the smallest number that I will divide 3087 such that it becomes a perfect cube? What I will have to remove from these factors? What I will have to remove? This 3 into 3, I will remove it. If the question asked me, then what is the smallest number that I will multiply? Then I will multiply this by 3. 1 again into 3 I will write. Understand? So, but in here asking, what is the smallest number that I will have to divide? That means from these factors, what factor I will have to remove? I will have to remove this 3 into 3. I will have to remove this 3 into 3 factor. Understand? So therefore the smallest number by which 3087 must be divided so that quotient is a perfect cube. This is equals to 3 into 3 equals to 9. I will have to divide 3087 by 9. Now another question asking that also find the cube root of the quotient. That means after dividing this by this, I will find an answer. That answer cube root I will have to find. So now I will write dividing 3087 by 9. So 3087 by 9, 27 I will get. This is 3, 8. This one I will get again. 3, 9 4s 36, 2 7 3s. So this gives me 343. Understand? This gives me dividing this by this. You write is equals to 3087 divided by 9. This gives me 343. Okay, now you see 343, this is equals to 7 cube. So therefore the cube root of 343, this will be cube root of 7 cube. Cube and cube root cancel, is equals to I will get 7. So therefore cube root of 343, this is equals to 7. Okay, next again you see example 11. Next again it is given our example 11. So example 11, 3 numbers are in the ratio 1:2:3. The sum of their cubes is 9, 8, 7, 8, 4. Find the numbers. Okay, 3 numbers are in the ratio 1:2:3. The sum of their cubes is 9, 8, 7, 8, 4. I have to find the numbers. Here. Understand? So solution. 3 numbers are in the ratio 1 is to 2 is to 3. The sum of their cubes is 9, 8, 7, 8, 4. I have to find the numbers. So in our lower classes, we have already learned that if the numbers are in ratio, we used to take in this way. Let the numbers be x, comma 2x, comma 3x. Okay, ratio is 1 is to 2 is to 3. So I will take, let the numbers be x, comma 2x, comma 3x. The sum of their cubes. So by quotient, it is given that sum of their cubes. So x cube plus 2x the whole cube plus 3x the whole cube. This is equals to 98784. This is given. So therefore I will get x cube, this one I will get 8x cube, this one I will get 27x cube is equals to 98784 I will get. So now these three terms, they are all like terms, x cube plus 8x cube plus 27x cube, they are all like terms. So I will add them. So 27 plus 8 I will get 15, 3, 35 plus 1 I will get 36x cube is equals to 98784. Understand? They are all like terms, so I can add them. Okay, so this one I will get 36x cube is equals to 98784. Now 36 I will send that side, so I will get x cube is equals to 98784 divided by 36. Okay, so this one if I divide it, I will get x cube is equals to 2744. Okay, x cube is equals to 2744 I will get. Now I want the value of x. Okay, I want the value of x. If I get the value of x, that value I will put it in this. Okay, I will put it in this, and then I will get the values of the three numbers. Understand? Then I will get the values of the three numbers. So first of all, I need the value of x. So x cube is equals to, I got this one. So I will take cube root both side. Understand? Taking cube root both side. Okay, this one I will take cube root both side. 2744. Okay, in here you can write that taking cube root both side. Okay, taking cube root both side. So this one I will get x is equals to this one, you break it into prime factorization. 2744, break it into prime factorization, you will get 2 1372 2 686 2 343 7 49 7 7 7 1. So therefore x is equals to cube root, this one you will get 2 cube into 7 cube you will get. Yes, 2 cube into 7 cube you will get. So therefore x is equals to, cube and cube root cancel, cube and cube root it will cancel out. So therefore x is equals to 2 into 7. So x is equals to 14 you will get. Okay, x is equals to 14 you will get. So therefore I can write, therefore the numbers are, are 14 comma 2 into 14 comma 3 into 14. So this is equals to 14 comma 14 into 2 I will get 28 28, and this one I have 14 into 3, 4 3s are 12, 3 1 is 3, 4, 42 I will get. So these are the three numbers, 14, 28 and 42. Okay. Next I will go to example 12. Okay, page number 70, example 12 I will go. Page number 70, example 12 I will go. So find the, in here saying, find the cube root of this one, 392 into cube root of 448. Find the cube root of this number. Okay, find the cube root of this number. So in here solution, this one you see cube root of 392 into cube root of 448. Okay. So okay, cube root of this number. So first of all I will take out the prime factorization of 392 I will do. The 2 1s are 2, 2 9s are 18, 2 6s are 12, 2 9s are 18, 2 9s are 18, 2 8s are 16, 2 4s are 8, 2 9s are 18, 7 7 7 1. So this is cube root of this one. I will get 2 cube into uh, in here. Okay, you write in this way. 7 into 7 I will get, and into again prime factorization of 448. This is again 2 2 2 4 2 1 1 2 2 2 5 6 2 2 2 is 4 2 8 is 16 2 1 4 2 7 7 1. So this is 2 cube 2 cube. So this one I will get 2 cube into 2 cube into 7 I will get. Okay, 2 cube into 2 cube into 7 I will get. So in here you see again cube and cube root, it will cancel. So I will get 2 into cube root of 7 into 7 I will get, again into this one again cube and cube root, it will cancel. So 2 into 2 into cube root of 7 I will get. So this one you see 2 2s are 4, 4 2s are 8, 8 into 3 7 into 7 into 3 root over 7. So this becomes 8 into this one I can write as cube root of 7 into 7 into 7. Understand? Because this thing we already know that square root of AB, this is equal to square root of A into square root of B. Similarly, cube root of AB also, it will become cube root of A into cube root of B. Or you can say cube root of A into cube root of B. This becomes cube root of A cross B. Understand? So that only I have done. So this is ultimately I will get 8 into cube root of 7 cube. So 8 into 7, this is equals to 56 I will get. So this is the cube root of this number. Understand? You can do it in this way or you can do it in this way also. Let me show you. Directly in here only we can do it. Cube root of 392 into 448. Okay, cube root of 392 into cube root of 448. I can write cube root, whole cube root I can give 392 into 448. Okay, so therefore cube root 392 prime factorization we have already done. 392 prime factorization we have already done. We got 2 cube into 7 square I got, and this one I got 2 cube into 2 cube into 7 I got. Yes, so now in here you see so cube root of this one 2 cube into 2 cube into 2 cube into 7 square into 7. So like term multiply by like bases are same, so power plus become. So this one we already know that 7 square into 7, this is equals to 7 cube. So this becomes 7 cube. So now cube and cube root, it will cancel out. So therefore I will get 2 into 2 into 2 into 7. So 2 to the 4, 4 to the 8, 8 7 is 56. This is our answer. Like that also you can do. Okay. So next our example number 13. Example 13 you see. Find the cube root. Find the cube root of 1.331 by 3.375. So therefore the cube root of 1.331 by 3.375. So this one is equals to, I can write as 1331 by 1000 by 3375 by 1000. Write the cube root properly. Okay, while writing cube root, you remember we write cube root as in this way. You give the root and in here you write 3. This if you write it in this way, it will be wrong. Okay, so therefore write it properly. This is cube root. So in here again we will do in this way. This becomes cube root of 1331 by 1000 by cube root of 3375 by 1000. Okay, so this one again is equals to, again in here I can split it. So cube root of 1331 by cube root of 1000 by again cube root of 3375 by cube root of 1000. I can again write it in this way. Okay, so now 1331, I will take out the prime factorization of 1331. I will take out the prime factorization. So 1331, this is 11. So in here you remember one thing, that you can take out the prime factorization, no problem. This is 11, it will go 1331, 1 is 11, 2 3, 2 is 2 2, 1 1, 1 is 121. So 11 11, 11 1 is. So this one 1331, this is 11 cube. Okay, 11 cube, cube root of 11 cube by, and 1000 it is 10 cube. Okay, 1000 it is 10 cube, cube root of 10 cube by 3375, this is 15 cube. Okay, 3375, this is 15 cube. So cube root of 15 cube by, this is again cube root of 10 cube. Okay, so again cube and cube root, everything it will cancel out. Ultimately I will get 11 by 10 by 15 by 10 I will get. Okay, 11 by 10 by 15 by 10 I will get. So this is equals to 10 10, it will cut. So ultimately I will get here 10 10, you can cut. So ultimately I will get here 11 by 15. This is my answer. Okay, 11 by 15, this is my answer. Okay, so either you can do it in this way, or if you are finding any difficulty, we can do it in this way also. 1.331 by 3.375 there. Cube root I will have to find. So this one you see, you can do it in this way also. Cube root of 1.331 by 3.375. Both numerator and both numerator and denominator we can multiply it by 1000. So we can remove the decimal. Both numerator and denominator we can multiply it by 1000. So this one we will get 1331 by 3375. So now you can split the root 1331 by cube root of 3375. So this is ultimately cube root of 11 cube by cube root of 15 cube, 11 cube 15 cube. So this one you will get 11 by 15. In this way also you can do. You understand? So there are many processes you see. From here another method I am showing. This one, if you want, you can write it down. Okay, let me show you in here. Another method you see. This one, cube root of 1331 by 3375. Yes, this one we are getting. So now this one, cube root of, this one I know 11 cube, and this one I know it is 15 cube. So 11 cube by 15 cube, this one I can write it as 11 by 15 the whole cube. So now again you see cube and cube root cancel out, is equals to I will get 11 by 15. So in this way also you can do. Understand? From here I am showing you, in this way also you can do, or in this way also you can do. It is your choice. Next again you see example 14 you see. Find the cube root of number 1 minus 5832. Find the cube root of minus 5832. Okay, find the cube root of minus 5832. So in here again I will take out the prime factorization of um, the prime factorization of 5832. So 2 are 4, 2 9s are 18, 2 1s are 2, 2 6 are 12, 2 1s are 2, 2 4s are 8, 2 5s are 10, 2 8s are 16, 2 7s are 14, 2 2s are 4, 2 9s are 18. This one it goes by 3, 3 2s are 6, 3 4s are 12, 3 3s are 9, 3 81, 3 27, 3 9 3 3 3 1. So therefore uh, therefore in here you see I can do 3 2s are 6, 6 3s are 18, 3 2s are 6, 6 3s are 18, 3 2s are 6, 6 3s are 18 I can do. So in here solution minus 5832 is equals to, I can write minus 18 into minus 18 into minus 18. Understand? Because you see in here 2 into 3 2 into 3 is 6, 6 into 2 3 3, one group you make, 2 3 3 one group, 2 3 3 one group, and 2 3 3 one group. So 2 into 3 into 3. 3 2s are 6, 6 3s are 18. 118 you got. Again, 3 2s are 6, 6 3s are 18 you got. Again, 3 2s are 6, 6 3s are 18. So minus 5832 you can write in this way. So this becomes minus 5832. This one it becomes minus 18 the whole cube. So therefore cube root of minus 5832, this will become your minus 18 the whole cube. So therefore cube root of minus 5832, this will become minus 18. This is the answer. You can do it in this way, or you can do it in this way also. You see here, you can do it in this way also. So cube root of minus 5832. Okay, this one I can write as minus 1 into 5832. So cube root of minus 1 into cube root of 5832, I can write it in this way. Okay, so cube root of minus 1, it will become minus 1 only, because why you see minus 1, I can write it in this way, minus 1 the whole cube, I can write it in this way. Okay, so is equals to minus 1 the whole cube. This gives me what? Minus 1 only, this gives me. So therefore minus 1, I can write it as minus 1 the whole cube into cube root of 5832. So this one you will get this cube and cube root cancel. I will get minus 1 into cube root of 5832. I have already taken out the prime factorization. So now instead of doing the multiplication in this way, I can make them into triplets. I can make them into a group. Okay, I can make them into a group where there will be three factors. There will be three same factors. Okay, so this is, you see, 2 cube, yes, 2 into 2 into 2, one group, again 2 into 3 into 3 into 3, one group, again 3 into 3 into 3, another group. So therefore I can write it as now 2 cube into 3 cube into 3 cube. Yes, I can write it as 2 cube into 3 cube into 3 cube. Understand? So now in here minus 1 into cube and cube root cancel. So therefore I will get 2 into 3, which is ultimately I will get, you see, 3 3s are 9, 9 2s are 18, 18 into minus 1, I will get minus 18. So in this way also you fill it. Okay, next one I'm showing you. You can pause the video and you can write it down in your copy if you want. If you have got any doubt, you please write it in the comment section, and if you want me to explain it again, I can do that also. You please write it in the comment section. Minus 216 into 1728. So solution. So cube root of minus 216 into 1728. So this one you see cube root of, I can do it in this way also. Let's find the prime factorization of 216. So this is 3, 3 7 3 to the 6, 3 3 to the 6, 3 4 the 12, 3 8 the 2 4 the 2 2 the 2 1 the. So this one I will get, you see 3 cube into 2 cube. So this one, first of all, you write minus there, no, one negative sign there, uh, minus 216 there. So minus you separate do and write. Okay, minus you separate do, minus 1 into 216 into 1728. So this is the prime factorization of 216 I got. Now I will take out the prime factorization of 1728. So 2s are 2 8s are 16, 2 6 are 12, 2 4s are 8, 2 4s are 8, 2 3s are 6, 2 2s are 4, 2 2s are 4, 2 1s are 2, 2 6 are 12. This is 3s are 3s are 72, 3s are again 24, 3s are again 8, 2s are again 4, 2 2 1s are. So is equals to cube root of minus 1 into 216, I can write as 3 cube into 2 cube into 1728, I can write it as, you see, 2 cube into 2 cube into 2 cube. 2 cube into 3 cube into 2 cube. 2 cube into 3 cube into 2 cube. So this is equals to this minus negative 1, you separate it. Okay, this one I can write it as minus 1 into cube root of 3 cube into 2 cube into 2 cube into 3 cube into 2 cube. Okay. So now this one I can write it as minus 1 the whole cube into, and this one it will become, you see, is cube and cube root will cancel. So 3 into 2 into 2 into 3 into 2, and this one minus 1 into this one become 3 to the 6, 6 to the 12. This is 3 to the 6 again. So 3 to the 6, 6 to the 12. 12 into 6 I will get 6 to the 12, 72 I will get 72. So this is negative 72. This is the answer. Okay. So in my book some pages are missing here. This 15 example 14, after I think exercise 4a in my book it is missing here. So next we will go to example 17. I will go. Okay. If you, after watching this video, you can send me exercise 15 and 16. Okay, in the WhatsApp you can send me exercise 15 and 16. Those who have my WhatsApp number, exercise 15 and 16 you can send it to me, and then exercise 4a also you can send it to me. Okay, mine here, that page it is missing. So next I will go to example, next I will go to example 17. I will go here. Example 17 saying that find the cube root of find the cube root of 17064. Find the cube root of 17064. So now you see cube root of 17064. So 17064. Okay, wait. First of all, I will take out the prime factorization. 17064. I will take out the prime factorization. You can write it in this way: resolving, or prime factorization of 17064. Whatever you write in the book, it is given like that. Resolving 17064 into prime factors. We have into prime factors. We have, so 17064 prime factorization I'm doing. I will get 2 8 16, 2 5 10, 2 3 6, 2 2 4, 2 4 8, 2 2 4, 2 6 12, 2 6 12, 2 2 4, 2 1 2, 3 3. This one 3. The 3 2 3 7 I will get 79. So 79 ones are. Okay. So now you see this one, I have taken out the prime factorization of 17064. So therefore I can write as 17064 is equals to, you see, I can write as 2 cube into 3 cube into 79. Okay, 2 cube into 3 cube into 79. So therefore cube root of 17064, it is equals to cube root of 2 cube into 3 cube into 79. Okay, so therefore it will be is equals to, you see here, cube and cube root cancel out, cube and cube root cancel out. So in here I will get 2 into 3 into, in here cube not there, power cube not there, understand? So 79, it will get the cube root, it will remain in here. Okay, 79 cube root of 79, it will remain. Okay, understand? On top of 79 cube root will remain, but in here 2 and 3 cube root will cancel out, because in here power 3 there. Okay, cube and cube root cancel, cube and cube root cancel, but since 79 does not have power 3, so cube root will remain. Okay, so cube root of 79. So this is equals to, you will get 6 into cube root of 79. Now in here, one thing it is, in your book the values of cube root of some numbers were given. That page in my book it is missing. If you can send it to my WhatsApp number. Okay, that cube root page is missing here. So this one, from that table you can find out the cube root of 79. Understand? You can find out the cube root of 79. Something value you will get. So 6 into that value you multiply it, you will get the cube root of 17064. That will be the cube root of 17064. Understand? It is given in the book. It is given in the book as 4.291. So if you multiply it, you will get 25.746. Okay, if you multiply it, you write this one in down, you write and go. In my inner space not there, that's why I'm writing in this way. Okay, so next example 18, we will discuss it in the next video. Okay, we will discuss it in the next video. I hope you have understood. If you have got any doubt or something you have not understood, please write it in the comment section. Okay, if you want me to again, I will explain it. I will explain it one more time. Okay, thank you.